Every invention starts with an idea.
We're trying to see how much play there is.
For Tahira Reed-Smith, her idea comes from a childhood passion. Double Dutch.
Growing up in Bronx, New York in the 1980s, double Dutch was just what you did as a little girl.
This double-roped version of jump rope was brought to New York by Dutch settlers in the 17th century. More recently, it became popular, particularly among black girls, in cities across the U.S. There are even fiercely competitive national competitions, and in some high schools, it's recognized as a varsity sport. To play, double Dutch requires 2 people spinning ropes in opposite directions, and at least 1 person to jump. Tahira dreamed of a machine that would allow her, an only child at the time, to play double Dutch whenever she wanted. In 3rd grade, she won a contest for that concept, and in the years that followed, she never gave up on that dream.
Major passion project. Talking about an idea that I've had for decades.
Today, she's a mechanical engineer and professor, working in human-machine systems. And she's building to her ultimate dream, to create an affordable version of her invention that people everywhere could enjoy. Meanwhile, another engineer, Sky Leilani, is working on her own double Dutch prototype. Sky works at a robotic software company.
When I was in college, I found Dr. Reed's double Dutch machine at a point where I was feeling like I couldn't get where I wanted to go. I was just surrounded by a lot of people who didn't look like me. I saw she was from the Bronx, which is kind of similar to where I'm from, and that really inspired me.
Problems that matter, that are informed by culture, that are informed by background, can stimulate the desire to get into engineering, the desire to go about this process of creating something that didn't previously exist. The problems which we decide are important enough to solve are influenced by someone's background and someone's culture.
Tahira has come to Vian Robotics in New York City to collaborate with Sky, bringing along her goddaughter, Sanai, part of the latest generation interested in engineering double Dutch.
When I first learned about Sky, it really touched me deeply because I didn't know that people were watching me from afar.
When I was looking at your designs, I was just like, wow,
I was just very encouraged by it, and I was also impressed by her passion and her excitement.
Sky isn't a mechanical engineer like Tahira is. She's iterated on Tahira's design, adding computer-controlled motors and a software interface to control the 2 ropes.
What are the traits of an engineer? I think it's hard to generalize. I feel like there's many different kinds of engineering. There's many different kinds of skills required in the different types of engineering.
She's modernized it, writing code to control it. There's vision for even an app, and doing everything largely through computer software and electronics. Very little mechanical engineering.
As Sky describes her approach, Tahira sees that Sky is running into a familiar problem: synchronizing the ropes. The ropes need to extend in a high arc, turning in opposite directions and staying 180 degrees out of phase with each other. In other words, when one rope is on the ground, the other should be directly overhead. As they rotate, they need to maintain a regular rhythm to truly create double Dutch. It looks easy when a person does it, but as Tahira and Sky know firsthand, it's anything but simple to engineer.
That was wrong.
The motor is always the most challenging aspect, and that is how it was with us. With double Dutch, the biomechanics that people use to get it to, it looks so seamless.
Yeah.
But trying to recreate that in a robot,
Yes.
you realize.
We have to ask ourselves, how does the biology do it with materials and information processing units that no engineer would dream of using. How is it that we can move both ropes so well at the same time, but a robot can't? So then the question is, what do we need to do to replicate that?
Look to your left.
Sky has chosen motors that are powerful enough to swing the ropes, with an added feature.
The motor for the double Dutch machine is from a hoverboard. They're DC motors with encoders in them, so they can track the position.
The encoder setup uses magnetic poles mounted on the motor's shaft. A nearby sensor detects the changes in magnetic field as the motor spins, tracking the motor's rotational position and speed with precision. That information can then be sent to a computer to adjust the spin in real time. At least, in theory.
A, B, A and C were running right now.
Not B. B isn't running, see?
For now, only 3 of Sky's 4 motors are spinning.
If these are 2 people's arms, it's just that it's like you step to the right.
Okay.
They decide to align 2 working motors so they can work with 1 spinning rope for now.
Let's just turn it on. Let's just see. Yeah, this is slow enough where I could actually just walk into it.
It's an impressive milestone. The 2 arms turning the rope are perfectly in sync.
Okay, stop it.
Oh my gosh, so good. I haven't seen anybody use it or anything this
Let's see.
It's really important, especially in sort of engineering projects where there's a consumer, to sort of take prototypes and actually test them with your end users to see what their feedback is.
That's what I love so much about this project is Double Dutch is collaborative, and then robotics as an entire field, it combines 3 types of engineering: mechanical, electrical, and software engineering.
After making some tweaks to the code, they decide to try a true double Dutch jump.
You want to hear the pat, 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 pat. Okay, can you take it over from me?
With 2 of the working motors, Tahira guides Sky to be a stand-in turner.
Just snatch it from me. All right, all right. There you go. Let me just try with a little bit that's here.
With Sky's assistance, the motors are leading the way. And they're working like a charm.
Oh, that's so satisfying. Oh my gosh.
Okay.
Thank you so much, Dr. Reed. This is amazing.
This is fun.
Working with Dr. Reed today was incredible. It was actually a dream for me. I felt like if I continue with this project, I'm gonna get there and then I'm gonna see myself as a different person who's capable of more than I used to think I was.
Meanwhile, after decades, Tahira is finally taking her own double Dutch design to the next level.
And when we've done small tests,
She's partnering with a product design company to turn her prototype into an affordable, consumer-ready version.
historically, what has been difficult has been how to design this system in such a way that it's fully functional and also cost-effective.
Which is why she still thinks that the most practical approach is to use only mechanical means to synchronize the motors. Tahira and Director of Industrial Design, Steve Escobar, are deep in the proof of concept stage. For now, they're working with a rudimentary plywood model to answer a few basic design questions.
Once you have an idea, how are you going to actually execute the idea? How are you going to design the idea so that people will actually want to use it? How are you going to make it accessible, both from a cost perspective, but also from a user interface perspective?
This first iteration of the design uses just one motor on each side, plus some good old-fashioned mechanical hardware, like gears, sprockets, and chains. Already, they're facing a few familiar challenges,
Looks like it's in sync, actually.
including getting the ropes in sync.
It's starting to go out of sync. Okay.
With years of double Dutch experience, Tahira knows exactly what the ropes should sound like.
We need to be able to hear a consistent pat, 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 but we're hearing It's very rhythmic. That's why when stuff's out of beat, it's like the whole, this is just wrong.
If anything slips, it would be a tooth.
Using gears is a common sense way to keep the rotation of the ropes in sync. But something is wrong.
We think the weight of the rope is throwing this off.
When it's in motion, it's actually creating too much force for these arms.
Let's take some of these off and let's see what happens. Let's see, let me just listen for it.
So how's it going?
Yeah, it's coming along.
Michael Sprov, president of Spec Design, stops in to see how things are progressing.
Where are we at, guys? How did we
As a team,
so far?
they talk about the day's testing and how to improve the design.
There's a lot to think about with some of the play that's still in the arms.
Your visit with Sky was very inspirational to us, and that was switching from a single motor with gears to 2 motors at each end. When you shared that with us, it really kind of turned the light bulb on.
It's extremely important to have different people who can see things from a different angle, because each one of us have our own blind spots.
Tahira's initial designs were rooted in her experience with mechanisms. But collaborating with Sky has expanded the possibilities for realizing the machine.
The best moments of ideation are, in my experience, collaborative, and they involve ideas bouncing off one another, being folded over, the negative of that idea being turned into the positive of this other idea.
Working together across different fields, what engineers call interdisciplinary collaboration can be a powerful multiplier. Though a lot more troubleshooting remains, Tahira's project is finally coming to life after decades of work.
Semi-surreal, exciting, it's a lot. It's heartwarming, it's... just glad. There's a message behind this product. When it gets on the market, there's a story to inspire young girls, young inventors, young minds, dreamers.